Hello, everybody. My name is Charles. I'm Cowboy D on Twitter, GitHub, pretty much everywhere on the internet. And I work at Frontside. I'm the principal engineer there. And we're a front-end agency, and we do work pretty much every day in both React and Ember, amongst other things. But at this point, this kind of comprises the core of our work. And so they're very, very different frameworks. And yet, working within kind of these such different environments really lets you triangulate on some pretty incredible insights. And it's actually one of those insights that I want to share with you today. It's a big one. It's kind of like profound truth. So, I know we've got high ceilings, but I'm hoping everybody can kind of hold onto their scalp so that it doesn't splatter all over the ceiling when your mind is blown. So if you're ready, here's what we discovered. Numbers can increment. It's true. It's true. Thank you. Thank you. Numbers can actually do a lot of things, but this is one of them. So we work with numbers a lot as developers, and so we see us incrementing, decrementing, doing these things on numbers in our code. So, for example, if you use Redux, you've probably written something like this pretty often. That's because we work with numbers. Numbers can be incremented. It's what we do. But it's not just in Redux, right? If we use another state management solution, this is what the kind of the similar code would look like in MobX. If you were using just raw set state in React, it would look like this. Or if you were in Ember, you'd have some action inside of a controller. And those, are all kind of different takes, different approaches for the same basic problems, and they're good solutions. But I do have one question, which is, why are we telling computers how to increment a number, right? I thought we agreed that numbers can be incremented. It's like something intrinsic about them, right? And it's not just numbers, right? The data that we work with everywhere, you look at it, and the fact that I'm working with an array means that I can push things onto it, right? If I have a value which is Boolean, I can toggle it. But just for argument's sake, let's really break it down to brass tacks. What do we have really when we have a Boolean value? It's simple, right? Well, for starters, we've got these two states that it can be in, right? We use these things all the time in our code, whether it's a checkbox or whether the state is a context menu open or closed. We use them. We use these states and we bifurcate based on which one they are. But those data, the states, that's only half the story, right? Because sure, we know there are two states, but what we also know is that there are pathways, well-known pathways, to navigate from one state to the other, okay? This is like a state transition, right? So we know that we can take a true value and we can toggle it and we can make it false. We know that we can take a false value, toggle it and make it true, or we can explicitly set a value to false, or we can explicitly set a value to true. And that's it. You could even say that those transitions, those operations, those define what it is to be a Boolean, like done, as in like epistemologically complete. It always has been, always will be. So, like in 19 billion years ago or whatever, when the universe was just nothing but kind of dust, there was like Boolean values hanging out there, waiting for life to evolve, mathematicians to come around and discover them. And when the sun dies and envelops the earth and we're all gone, Boolean values will still be out there hanging out there. And so a Boolean's a Boolean. That's just what I'm trying to get across. And those transitions that go from one state to the other, they do not change. We know them. We know them before we even started writing code. So, but if we know that a number is a number, and we know that a Boolean is a Boolean, then why on earth are we doing this every single time, right? We keep pasting the same boilerplate with a different way of pushing the numbers around, but it's the same operation, just embedded in a different context. And so I've been talking a lot about numbers, incrementing, Booleans, things like that. You might be saying like, okay, I think let's not get out of hand. It's not that big of a deal. And if it just ended right there, I would probably agree with you. But of course, primitive values like Booleans, numbers, those are just the beginning. It's not working with the individual ones. It's when you start to put them together with other values that things start to get out of hand. Because, right, you got this little Boolean. It's cute, it's adorable, it's harmless, right? How could this hurt me? But the problem is that Boolean grows up to be the completion status of a to-do item, right? And that to-do item then becomes an array inside a to-do list. And suddenly, our sweet little Boolean takes 3 operations, 3 levels of nesting just to get down and to toggle. So here's what this looks like. That toggle looks like in a reducer. And you can see that most of what's happening in this reducer is actually unpacking context, twiddling the Boolean, and then packing the context back up. And so like literally the most important piece of the operation is all the way in the center and all the way to the right, where it absolutely shouldn't be. And this is just a toy application. It can get difficult to manage this value, which kind of makes you want to scratch your head and say, wait a minute, does it need to be this complicated? I thought we were working with numbers, Booleans, and arrays. They increment, they toggle, they push, things like that. What we would really like to be able to do is say, well, let's just have a number that we can just say, we can declare that we want to increment it, and we don't actually have to push the beans around of the actual integer values in memory. Or, same thing with a Boolean. We can say we want to transition from one state to the next and just declare that as an operation rather than saying how that operation takes place. And the same thing if I could just push, a to-do item onto an array and just have it work, right? That's kind of the API that we want. And what, the next level is then taking those primitive structures and being able to combine them into bigger superstructures. Well, there's this kind of pervasive concept in programming, always keeps popping up no matter where you go. Doesn't matter if it's static, doesn't matter if it's dynamic, we always arrive at the concept of type. Right? Numbers can increment. That's what they do. That's their type. They are described by the things that you can do with them. And yet, the problem is with a lot of the systems we work with today, we're essentially building them untyped, right? I'm not saying that the JavaScript code here is like untyped, but we use typed JavaScript to build untyped code. It's like using Haskell to build a bash interpreter or something like that. And so, a quick divergence, you might be thinking, well, this is a solved problem, right? What about TypeScript or, Flow or some statically compiled to JavaScript language? Those have amazing type systems. And I would agree with you. I'm actually a big fan of static typing. But what static type checking does, that helps your development process. It helps you at build time. By the time your code's actually running, your static type checker has like wiped its hands, it's done, it's work, it's out, it has no trace in your runtime. What it doesn't do is it doesn't provide an action or a transition, literally a JavaScript function that you can bind to, say, a button. So what then? If we're looking for types, we want to use types so that we can declare the valid operations on a piece of data in one place so that we can then take that code and embed it literally anywhere. But we only define that operation once. It's kind of almost like what we're looking for is JavaScript. I know it's a revolutionary concept, but JavaScript, the framework, has a lot of real advantages. There's not a mental model to adjust to, and this is a big one. It works, it works with any framework that you care to use. So, for example, I can use the JavaScript technology to capture in one place, once and for all, what it means to increment a number. There's that code that we saw there in the reducer, in the Ember controller, in the MobX class, and in the React component. And then I've got now what a number is. I've got it. I can put it anywhere, right? I can increment it because that's what I do. I've captured the type. And I can use that and I can compose that to build more complex things. So I'm going to take this number here and I'm going to embed it into a person to represent that person's age. Okay, and now I can declare a new operation, which is to celebrate the birthday, which advances the year by one thing. I haven't said how I'm managing the number that represents that year. I've merely chained the operations of celebrating a birthday to incrementing a number representing the year. Okay, and that's nice. It's very clear what's going on here. It's very obvious, right? This is vanilla JavaScript, but there's one hiccup here, and probably a lot of folks in the audience are already keen to it, and that is the code that I've just kind of showed you. This pseudocode. Actually, it's not pseudocode. It's real code. It's using mutation to affect these state transitions, which for a lot of people, in a lot of contexts, myself included, is really a bad word. And there's a lot of reason why mutation is really, really bad. But guess what? There's also a lot of reason why immutable API is really, really good, right? And there's a lot of good reasons. And the biggest one in my mind is that they're easy to understand, right? They compose well. I can take a number and I can just say, boom, I can just set it. You belong to this person now. And I have now taken these two separate concepts and I have put them together. And that's actually, that can be really nice. It's easy to understand. As if you're a developer coming into a code base, you can just see it. And that's why, they can be enjoyable to work with. They line up with the way that we conceive of the world. But the problem is when you actually take these mutable APIs and try to, put them in a reactive system, it gets really, really hard. And the complexity of the situations that they handle as your runtime, increases loads of the number of events it's handling and all the stuff that's going on, to actually manage that, it takes a really, really heavyweight system, usually provided by your framework, or a massive open source project like MobX to actually manage that complexity. And so they do a good job of it, but it's like you need a gorilla to have your back. There's no way you could do that yourself. By contrast, with immutable systems, you give up that understanding in exchange for that simplicity at runtime. I mean, I appreciate Redux and I've been working with it for a really, really long time, but for a code base of any significant size, it is still difficult for me to fit what the heck is going on in my head. Just because the pieces are everywhere, kind of lying around, but it provides these awesome advantages of immutability. It really simplifies your system at runtime for complexity when you're actually analyzing your code. So the advantages of immutability are absolutely real, and I subscribe to them. But it means that you always have to come to this decision: do I want to trade an API like this, for this, right? And the answer is not always clear. Like sometimes it's yes. And it's just kind of one of these trade-offs that we have been we've just come to accept on faith that it is necessary to make. And so, the question I ask is it really necessary? And I think the answer is no, actually not. We can actually salvage this with just a few kind of tweaks to the syntax and a little sprinkling of functional programming fairy dust. We can actually have our cake and eat it too. And so the key here to this little tweak in the API, it actually takes a little bit more work to make this API work. But the key tweak here is that instead of editing the number in place, we're actually returning returning the person in place. We're actually returning a new person entirely. So you can see down here, I'm actually returning a completely new person. The old person is not changed at all. We just have a new representation of that person with some of the attributes being a little bit different. And kind of to call out explicitly what's going on here is this composition of these two types. we're actually generating a new number right there, which then gets rolled into a new person, which then is what's returned. And that process can continue ad infinitum. So I could take that person, roll it into another object, roll it on all the way up. And so making this little tweak is exactly the approach that we took with a library called microstates. We spent a lot of time actually researching that functional fairy dust that I just kind of hand waved over. It's there, but I don't want to dwell on it because what I really want to do is focus on the API. Because while I would very much like for everybody here to try out microstates, I'm not here so much to pitch the library so much as the idea behind it. And that is having a minuscule API that imposes just enough structure to reap some really key benefits, but for the most part, relies on composition rather than features, just like components do in literally every web framework these days to scale to complex use cases. So I can have a simple thing like a number, and I can embed that into a person as their age. I can take that person, put them into a session, and I can have an app that has a session, right? But at no point do I need to express the operations for those data because they're just all implicit to the type, right? The operations come with the data. And so, I think there are really, really some key benefits to this approach. So let's go over a couple of them. So we've talked about this before, immutability. I think most of I don't know where folks fall on the debate, but most of the discussions around immutability fall around things about determinism, time travel debugging, things like that. And those are great things, but I think there are also kind of smaller workaday quotidian benefits that actually improve your developer experience if you're using an immutable interface. And so that I wanted to focus on those here. So the first is if you are using, and I should mention that I think they work especially well if you're using kind of a plain vanilla JavaScript approach to immutability, as opposed to something a little more grandiose. So JavaScript, turns out, has these great things called getters, right? They're computed properties. And if your object is immutable, you can use them completely and totally without fear of reprisal. And you don't need decorators. You don't need any special runtime stuff. If your object is never going to change, then the values that are computed off of that object are also never going to change. So it's completely and totally safe to use them, right? You get a fresh copy of the object every single time. Another way to think about this is, if you want to use the jargon, is that the getter is a pure function of the this object. So if this never changes, then the getter must always return the same value. So it's completely safe. You're relying on the identity of the object for your reactivity, not anything that's listening to that getter. The second thing is that because this object is immutable, it's always 100% safe to cache those computed properties, right? The object can never change, so the value of the property can never change. So you compute it once, you compute it a billion times, and so you might as well keep the result of the computation around forever. And because of this, microstates, for example, just does that for you. It will memoize automatically computed properties. But again, there's no ceremony around computed properties. It really is just JavaScript. So the other thing, and I think this is actually really cool, is you get what's called value stability. Or, again, the FP jargon is referential transparency. But that's just saying that are the things that actually changed the things that changed, right? That's kind of weird thing to say. Is the thing that changed the thing that changed? Or is it another thing that represents the thing that changed? So to kind of decipher that statement, maybe you've used something like key attributes. Every framework pretty much has a variation of this. This is what it looks like in React. But your framework needs it because very often there are different objects coming in that actually aren't different objects. They're different objects that represent the same objects. And so the framework needs a way to disambiguate from actual change, from like change that's just incidental change as part of just the spinning of the wheels of your app. But a system like microstates actually does not need to provide rendering keys ever. And that's because it has this concept of value stability. And it can do this because we built up those tree of objects as a set of completely and totally encapsulated nodes. And so it can reason about the tree in its entirety. So if, for example, I make a transition at this node, right, that's going to result in a new tree because we're immutable, where that node is changed and everything, if you trace back up to the root of the tree, everything is changed. Okay, and those things, those objects do need to change, right? But every other object doesn't need to change. It should be the same, and there's no reason why that shouldn't be the exact same object, no matter what kind of data you have. And so, what I mean, it is literally the exact same object. And that's really nice. It's nice as a developer because I don't need to worry if something is a different object entirely or just some other object, some different object representing the same old object. Another way of saying that is you can just use triple equals everywhere. It's really nice to just be able to rely on that as just a basic fact. But it's also nice to your framework too, because it helps optimize the render cycle without kind of any intervention on your part. So I have like just a little video to show this in action. And this is, I'm going to be using React with a bunch of different state management solutions. And we're going to be seeing the render updates. Okay, React DevTools has this neat feature where you can see what's re-rendering at any time in reference to what's happening. And so every time, just to kind of show what you're going to see here, every time a component re-renders, it gets a little box rendered around it. Okay, so what we want to see actually is as few re-renders as possible. And what we really want to see is no re-rendering that's not related to the thing that's changing, right? So if I've got a component that I'm editing, yes, I want that thing should be re-rendering, but all the other stuff in the app should not be re-rendering. So here is set state. And as you can see, is I'm literally typing into the box. Every key press results in everything being completely re-rendered every time. And that's just because it's creating a bunch of incidental objects. This wasn't, even though this is the kind of the given example for how to do MVC with set state, it's not optimized. So it's doing a whole bunch of unre-renders. Redux fares a little bit better in the sense that you can see that while I'm typing, nothing is rendering, and then while I'm entering the text, only that text box is re-rendering. But when I add an item to the list, every item in that list re-renders. And when I take an item away from the list, every item re-renders. And that's because the store is not doing, it's creating new objects and not kind of tracking and saying, hey, it's not making the minimal amount of change. And so we've got, it's doing a lot of spurious re-renders. That's the other thing is when I'm filtering, it's also re-rendering every single component in there. It's a similar story with MobX, where it does better out of the box than set state, but again, I filter those lists and it's re-rendering the components. I should only be changing the list. So here's the demo with microstates, and you can see as I'm typing into the box, only the box and its container is changing. And then as I'm filtering the lists, none of the individual components need to change because they're just occupying a different list, but it's the same object, right? It's the same thing. And so what we get there is we get, performance without optimization, right? Because when you need to do performance tuning, it's always the least convenient time to do performance tuning, right? It's like, oh my goodness, everything's slow and you need to rely on a set of expertise and skill sets that may not be available. You're like, oh my goodness, we need to get this really senior person or someone who has a lot of experience with profiling JavaScript to find out what the heck is going on, and then we need to optimize it. But if we can just do the right thing by default, right? If every object that doesn't change is always the same object, always, we won't be in that position. So what I'm getting at, when I'm talking about, this stability, performance, all these things, is that there's actually a lot of things that we don't consider often when we're choosing a state management solution. Is it immutable? Is it composable? Is it scalable? Is it performant? Is it even legible? Right? I think that's actually, having a thing that a developer can just come on and see what your state looks like. That's important. It's a valid concern, right? And so I'm actually, at this point, I get to be the guy who actually talks about jQuery. When Tara said that, I was like, oh my God, I have a slide that says jQuery. But I think it's actually, there's a good analogy there. Because I feel like today's batch of state management tools kind of feels like the jQuery ecosystem did back in the day. I don't know if you were working with jQuery then, you had to choose very carefully what kind of plugins you were going to use because they didn't really talk to each other. You'd have problems with them behaving differently. You'd have a different user experience for different parts of your app. They'd be themed differently, and it felt a little bit cobbled together. And so as a result, when you'd have these islands of functionality that were kind of orbiting one particular jQuery thing pop up in your application, and they didn't communicate with each other. And so, that was the reality, and those were not the good old days. That was not fun. But then something really wonderful came along. It was the component, right? And, if you were doing dev back then, think how terrible it was before components, right? It was terrible. But components came along and it changed that, for pretty much every framework, right? That's how we think now is in terms of components. But it wasn't always like that. The component has really, really simple API. It's really, really simple semantics, but yet what gives it its power is the way you can click it together like Legos. I mean, the talk we saw yesterday about the render props really was a great demonstration of that. It's like the kind of the mind-blowing composability that you have when you've got components in your toolbox. And so, that focus on composition is what really has made this revolution possible. So I feel like we're kind of living now in a jQuery era of state management, where we have a lot of different solutions. A lot of them are highly framework specific. And more often than not, you've got, little islands of state around which different parts of your application sail. I know in one of ours, it's like keeping in state the sync between React Router and the Redux store, right? And there's 3 libraries just to help you deal with that. And so I think, there are a lot of different tools for state management that address one particular use case really well. But I think that's maybe not what we need right now, just in kind of the same way that the way to fix the jQuery ecosystem was not a new jQuery plugin that was just going to do more for you. I think what we need is a new state primitive that unlocks the potential of that cohesive state in our applications. Microstates is our attempt to build this small, but infinitely composable primitive. But even more so, we see it as a conversation starter. A conversation starter about the need for a state management solution that has you covered, just kind of out of the box for things like performance, things like composability, things like simplicity at runtime, and absolutely for, legibility. A conversation about state management that doesn't force you to trade away the things that you shouldn't have to. So if that's a conversation that you're interested in having, please do get in touch. Thank you.